Welcome to Kitchen Chemistry, a series where we do a few experiments in my home and you can copy them along in your home. Mostly in the kitchen, obviously, that's why it's called Kitchen Chemistry. This is aimed at people of all ages, and so there is a mixture of different difficulty levels and different understanding levels of chemistry. But never mind about that, let's do some chemistry. If you need to know about safety, which you do, read the instructions in the text below. So what we need for this first bit is a cooker, someplace to heat something up, some water, some baking powder, which is sodium hydrogen carbonate. It's a normal baking powder, which is actually rarer than baking soda, which is what you normally use for making cake with. We need some baking soda as well though, so we'll be good with that, and we'll test which is which in a moment. We also need something to heat it up in, a pan for example, and some glasses to look at what we're doing. Water's in my list twice, I noticed. We also need a wooden spoon to stir stuff and some kind of thermometer to measure things. Ideally a cooking thermometer, because they go up past 100 degrees and so we can measure higher temperatures than a normal thermometer. Later on we'll need some sugar, quite a lot of sugar actually, maybe about 300 grams. That'll be all for today. We'll need some other equipment next time. What we're going to do now is we're going to test our baking powder to make sure it's baking powder and our baking soda to make sure it's baking soda. The easy way to do this is to pour it into a glass like this and add some water. Because the baking powder is supposed to run at low temperatures, we can see this reacts immediately. I'm going to switch microphones now so you can hear. So let's put that aside and have a look at the other one. If we take some baking soda instead of baking powder, the original, so you notice I'm not measuring this because I just want to see whether there is a reaction or not. We'll use a teaspoon for the next step. If we put baking soda in some water, we can see it doesn't react. So now what we're going to do is we're going to take some boiling water, this is fresh new boiling water, and add some baking soda to it. The baking soda was the one that didn't do anything when it was at room temperature. We throw in a generous teaspoon of baking soda into this, and we expect something to happen, because if we do some baking, it reacts and there it goes, all fizzy, as you would expect. I'm not bringing the sound up to this one because it's all full of steam. If we measure the temperature, it's about 80 degrees, I believe, something like that. It's nice and hot, and it causes the reaction to go very fast and be over in a very short time. You can see that easily for yourself. So a quick look at the chemistry there. We've got sodium hydrogen carbonate, NaHCO3. That's the thing in the middle on the left right there. If we heat it up, we need two of those and they react with themselves to form sodium carbonate, Na2CO3, plus water plus carbon dioxide. That's the thing that fizzes off when it's hot in the hot water. If we mix it with acid, it reacts with the acid instead to form H2O. So the extra H plus from the acid adds onto it to form H2O and carbon dioxide and forms a new salt of the acid. So it's the sodium acid minus salt. In the case of the baking powder, it already has an acid added to it. And so when we add water to it, the acid reacts with the sodium hydrogen carbonate. In the case of the baking soda, you see I'm getting confused here, it's really difficult to say these things. In the case of the baking soda, there is no acid in there, and so it can only react if it's heated up. It's somewhat simple, although as you can see, lots of elements get moved around and it looks kind of ugly. The interesting thing about it to us today is that the reaction can be caused by heating it up, or it can be caused by mixing the acid and the base together in water, where when they were mixed dry they couldn't react. Starting again with some fresh boiling water with nothing in it apart from whatever comes out of the tap, we can see on my thermometer it boils at about 100 degrees. It's slightly below, but if I move it around it gets to about 100 degrees. So that's good. That means that my thermometer is not broken, which is also good because it was new, especially for this. And now we can do something more exciting with it. So what I'm interested in now is adding some sugar to my water to see what happens. If we dump in a sugar bowl full of sugar into this water, so it's about 250 milliliters of water and about 100 grams of sugar, it's going to change the boiling point probably. What you can see if you do this, and you can see from my video, is that when the sugar is added to the water, it stops boiling. We're going to go forward a bit to see it boiling now. As you can see in fast motion, I'm going to add a little bit more sugar to it because it didn't really have very much effect. It takes quite a lot of sugar to do anything at all. So we're going to have 2 bowls of sugar and stir it around really fast and then heat it up. And eventually we will get to boiling again. Once we're at boiling point, we can have a look at the temperature and we can see that it's boiling at much higher temperature than boiling point. Well, 104.5 degrees. 104.2 degrees. A simple explanation for this would be that the water molecules get in the way, so we need a certain amount of water molecules that have enough energy to leave for it to boil. And if some of those molecules are replaced with sugar molecules which can't evaporate because they're way too big to do that, then the water has to be hotter before it can boil, before all of those have enough energy to leave. This process is really sweet making. What you do when you make sweets is you mix water and sugar, you heat it up to boiling point, which is higher than the boiling point of water, and during boiling, water evaporates, water is lost as steam, and the sugar stays in the pan. So as we continue to heat it, the boiling temperature will increase and increase as the amount of sugar goes up and up in the pan and the amount of water in our kitchen goes up and up. And so we can get a new concentration of sugar in our sugar, effectively. This is how we make sweets, so we can use the boiling point of the sugar to measure how much water is left. And if we choose the correct boiling point, we can stop at our sweets once we've heated it enough. So back to our cooker. We need 100 grams of sugar this time. We need 2 teaspoons of baking soda. Make sure it's baking soda. Ideally we'd have some corn syrup, but I only had maple syrup. It didn't work very well with maple syrup, but corn syrup is better, or invert sugar, as it's also known. What I'm going to do is dissolve the sugar in 40 milliliters of water, heat it up to boiling, and measure the boiling point as it increases and increases until it reaches 130 something degrees, 137 on the recipe. I did it a bit lower. Then we're going to take it off the hob and put in 2 teaspoons of baking soda. It will fizz up because it's well above the 60 degrees needed to cause the baking soda to react, and then the bubbles will hopefully be trapped inside the sugar and we'll end up with fizzy sugar. That's the idea. I'm going to pour my fizzy sugar into this silicone baking form. You can use a normal baking form, it works just as well. That's just fine. These silicone forms are a bit soft when they're hot, so be careful with those. And if you use a normal baking form, make sure to give it a bit of a grease beforehand, because sugar loves to stick to things. It'll be really hard to get it off. And you don't want to spend all day doing that. And off I go. I'm about to put the sugar into the pan, and I will add some water, the 40 milliliters of water, and then I'm going to add some maple syrup. I didn't really measure this. Recipes vary quite a lot as to how much of other flavoring you should add, So I've just given it a metric bit. Then I'm going to heat it up to boiling. It's going to take a while. It's supposed to do this relatively slowly, so sweet manufacturers recommend that you take a long time doing this. Obviously, I didn't take enough time doing this and mine wasn't very good. You can spend more time and be better. Make sure you don't get any on you, it's really hot. While I do that in the background, I can tell you what's going on. So we're heating up sugary water, boiling off the water, and measuring the temperature to effectively measure the concentration of the sugar as it goes up and up as water is boiled off, because the temperature of the boiling is determined by how concentrated the sugar solution is. Once we've finished doing that and get to the temperature where we think it's going to work, where it's going to go solid, then I'm going to add some sodium hydrogen carbonate, some baking soda, which doesn't react at room temperature, but reacts at about 60 degrees, so the reaction will start immediately. It's added to the hot sugar solution, which will be at about 130 degrees by that point. And it won't be boiling very much. We're about to get there. So it will be not boiling, but very hot. And then we'll add some baking soda, and it will react immediately, generating some carbon dioxide, lots of gas, and some water. While it's doing that, the sugar will be cooling down and going hard, and so it will effectively freeze the bubbles made by the carbon dioxide into the sugar, making a kind of honeycomb. Now I'm going to pour this foamy mixture carefully without splashing it onto myself, because it is 137 degrees, into this silicone baking form. You can see I probably could have made quite a lot more. And then I'm going to let it cool down for an hour, because it's very hot at this point and it's easy to burn yourself. Also, it takes a long time to go solid. The pan is also very hot at this point, so we need to let it cool down before washing it. And that's all there is to it. We've made a simple recipe using two parts of physical chemistry, increasing a boiling point by dissolving things into liquids and causing reactions to run if we heat them up more than they do if they're cold.